Okay, so I'm going to go ahead and explain the inverse of sine, cosine, and tangent. I don't really like calling them the inverse simply because later on in Trig you'll learn about reciprocal functions and the notation will actually confuse you. I like calling them arc sine, arc cosine, and arc tangent. Now with sine, cosine, and tangent, when we use those, we're using those to actually find a leg. When I have an angle and I have one leg, I can find another leg by using that rule, the rules of the ratios for sine, cosine, and tangent. In this case, I actually want to give you two sides, or maybe even three sides of a triangle, and ask you to find an angle. So the arc sines, arc cosines, arc tangents are going to be used to find angles, not lengths of sides. The way that I would remember to keep it straight in my mind is that sine, cosine, and tangent, they don't start with an A. They start with a regular consonant. But arc sine, arc cosine, and arc tangent all start with an A, meaning you're going to have to try to find an angle. So, first thing, let's talk about the notation. So normally we would get sine of some random angle, but we're going to actually put a little, like a -1 exponent on here, and that's going to be read as arc sine. And we're going to do arc sine. Now sine is opposite over hypotenuse. So if I give you arc sine and you have if I give you the opposite of hypotenuse, you're going to take the arc sine to actually find your missing angle. And then the notation stays the same for arc cosine. Cosine is adjacent over hypotenuse. So if you have the adjacent or the hypotenuse, or the adjacent and the hypotenuse of a triangle, you can take the arc cosine to actually find the angle. And we can do arc tangent. Arc tangent is opposite over adjacent. So if you have the opposite and adjacent side of the triangle, you can actually use this to find the angle. So a quick example of this is simply, we have a right triangle, and let's call this theta right here. That's a better theta. And let's just say this is 9, 40, 41. And I actually want to find theta. So theta here, all I know about one angle is 90 degrees. And I know that theta plus this other unknown angle up here, they're going to have to equal 180. But I know the three sides of the triangle. So I can actually use these rules. I can pick any one of these three because I have all three bits of information. So let's set them all up. So let's look at arc sine. So we're going to have arc sine, and we're going to look for opposite over hypotenuse. So my theta is here. Going directly opposite is going to be my 9. So I have 9 over, and then my hypotenuse is 41. I can do arc cosine. Arc cosine, if you remember in class, we draw that little arc right there. And if the arc touches in two places, or you can even put your finger on there, the arc is going to touch in two places on the hypotenuse and the adjacent. So my adjacent is 40, and my hypotenuse is 41. And of course, then we could still do arc tangent as well. Arc tangent, if you remember, tangent is opposite over adjacent. So my opposite, once again, directly opposite of theta is 9. My adjacent is 40. Now you can type all three of these in the calculator, but you're actually going to get just one answer. These will all equal theta, and conveniently, when you put this into the calculator, the angle you're going to get is going to be approximately 12.68 degrees. So theta here is 12.68 degrees approximately. Now from there, we could actually find this. Hi, I'm Mr. Buzzard, and I'm making these videos as supplemental instruction for my students. If you found these videos actually informative, or they answer the question you're looking for, make sure you hit the like button, and then don't forget to subscribe, and then click the bell to receive notifications for future instructional math videos.